So I'm here at the NMR instrument. The first thing you need to do is to make your NMR sample, and the best thing to do is to just to make it in a clean, brand new test tube like this. You could weigh this first on the scale. If you wonder how to weigh this best, you could tear the scale with a small beaker on the scale and then put this in there and weigh it again, and that way you can get the weight of the test tube. And then go ahead and add your unknown sample in here. Now you want to shoot for somewhere around a few milligrams to maybe upwards of 10 to 15 milligrams. Much more than that is really not necessary. If you by mistake maybe get like 20 milligrams, that's probably okay. You don't really want to have much more than 20 milligrams in an NMR sample, especially given that we're using a high resolution NMR which locks on to the solvent signal. And because of that, you want the majority of the material that's in your NMR sample, NMR tube, to be the deuterated solvent, not some other material like your analytes. So anyway, get your sample in the test tube and then weigh it again, and then you want to get a deuterated NMR sample. NMR solvent. Notice that this bottle, you probably can't see it, but it says chloroform D to indicate that the one hydrogen that is present in the chloroform in this bottle here is actually deuterium, the heavier hydrogen isotope, not the regular hydrogen. And for that reason, as you can imagine, these are really expensive liquids or solvents because it has a special heavier isotope only and not the regular isotope for hydrogen. So please be careful not to waste this. Okay, and also these bottles of deuterated NMR solvents are used for really sensitive analysis, and some of these are used for important research activities that happen here on campus as well, that rely on precision analysis. We even have NMR analysis projects we do for a pharmaceutical company, and you can imagine that needs to be extremely accurate and precise and whatnot. So anyway, every time you take a sample or a solvent out of one of these NMR solvent deuterated solvent bottle, please make sure that you're using a brand new Pasteur pipette, the glass Pasteur pipette, so that there's no contamination. And you use the pipette to take out solvent out of here once, and please do not reuse it. If you are in any doubt, always use a brand new pipette to draw out solvent from an NMR solvent bottle. And then you can put after you place your sample in the test tube, you can pipette into this your NMR solvent. And when you do, when you take up the NMR solvent into your Pasteur pipette, about that much is more than plenty. In fact, I think I took a little bit too much in here. And then you will go ahead and pipette that into your test tube that contains your unknown sample. And then you can pipe it up and down like so. And when you're doing that, make sure you're not just letting go of the pipette bulb all of a sudden, because if you do, the liquid can get sucked up into this Pasteur pipette so suddenly that it can shoot up into the bulb, and that's gonna be a huge source of contamination that we don't want to see. So you wanna let go of the pressure on the pipette bulb gently. That's always a key pipetting technique in chemistry. And then once you take up a sample here, you can place that into your NMR tube, and the goal is that you want to have about this much height in your sample NMR test tube. And if you're very meticulous, you should know that this is supposed to be 5 centimeters or 4.5 to 5 centimeters, and the reason is that that's the exact length that the probe in the NMR machine right here interacts with the sample. And what the next thing you do will be, now once you have your NMR sample ready and the height is about right, and if the height is not quite enough, you can add a little bit more of the deuterated NMR solvent, but I cannot stress this enough. Please use a brand new pasture pipette. Go get a new one, because you do not want to contaminate these at all. Okay. Once you get this tube ready, the next thing you want to do is you want to find a chem wipe, which usually looks like this. That's a lint-free tissue, so unlike, it's not at all like Kleenex, so please don't use a Kleenex or even paper towel for this purpose. And you want to take a chem wipe to wipe down the NMR sample. There should be no stickiness or any sort of, or really anything on the surface of the NMR tube. This will actually make a huge difference in NMR, and it will actually lead to you can actually cause some malfunction in the NMR, and that would be a really hard thing to fix in the probe, because the bottom of the NMR probe, the thing that sits right here, has to come out for me to clean that one. So please make sure it's clean. Okay. The next thing you want to do is you want to get a floater. Now, please be careful with these. These floater, it may just seem like an innocuous plastic piece, but if this gets dropped, it will get deformed in a subtle way that even if we can't see the deformation, it will make a difference in NMR measurements. If you do drop this, please let me know, because we probably do not want to use that floater, especially for research purposes. So anyway, once you grab your tube, you want to insert this through the this is called a floater. But before you do, I just want you to be aware that this thing could be pushed up or pulled out. The proper orientation is that this bottom part is pulled out as far as it extends. So pull on this to make sure it's extended all the way out. If you do, make sure that your gloves are clean, because this is the part of the floater that will go directly into the NMR probe that needs to be extremely clean. And then remember, we clean this with chem wipe, goes through the metal of the floater, and this will now go into the depth gauge. It looks like this. This is another precision instrument, so please do not drop this. Okay, this goes in here, and what you do is you want to push the tube to the bottom here, and oftentimes the tube doesn't go all the way to the bottom, so that it's not quite touching this black plug. And if that's the case, what you want to do is push down on the tube and then give it a twist. Okay. Now, I forgot to mention this earlier, but make sure that your tubes are labeled. The best way usually to label your tubes is actually to label the cap right here like this. So there's enough information on here for me to know what it is, and including the date. Some of you might find it difficult to put the date on your NMR cap. You could also write stuff on this part, but please don't put any tapes on the tube, because that will absolutely interfere with the NMR operation. So, okay. So once the depth is set and this is all clean, you can take this out. You can give it a little bit of a wipe here on the floater, so that the part that goes into the probe doesn't have any sticky residue or anything like that. So now this is ready to go into the what's called the carousel that will sit on top of the NMR. So this is the carousel. I have taken it off of the NMR. Normally it sits on top of the NMR magnet right there. And this will go into one of the slots. And the most important rule about the carousel here is that right now, check with your instructor or lab assistant, but right now we have it set so that the routine maintenance sample is always in slot number 24, which means that even though I don't see the sample in this carousel in slot 24, that sample is actually in the magnet. In fact, you could see on the auto sampler that the sample 24 is inside the magnet in the probe right now. So if anybody puts a sample in slot 24, that will collide with the sample inside the magnet, and that's going to be a disaster. That, well, let's just say that's going to be a real disaster. So please don't put anything in sample slot 24 under any circumstance. Now that potentially could change, so ask the NMR maintenance person. That also happens to be me. But the slots that are available for the class purpose are slot number 1 through 10. All the rest of the slots, even if they're available, like this slot 18 here, I just want you to know that those are reserved for the researchers and other users outside the class student users. So please respect that and use the slots 1 through 10. And usually not that many students are using this at any given time, so that should work out fine. Now, if there's a need for more slots, your instructor or a lab assistant might make more slots available for you, but listen to that instruction about the slots. But usually it's the slots 1 through 10, and never to put anything in slot 24. So in this case, I'm just going to put the sample I have in slot number 1. Remember, 24 is bad, okay? I'm going to put this carousel on the auto sampler. So I just installed the carousel, but this is a part that normally is only done by either your professor or trained research students or lab assistants that are specifically trained for this. One of the reasons is that this magnet is floating on air with an air compressor, air pressure. And so if you lose balance and put your hand on here with your weight, the magnet will all of a sudden drop. And that shock sometimes is enough to damage the magnet inside. What you're looking at, this is the dewar for containing cryogens, liquid nitrogen and liquid helium. You may have seen me or somebody fill the magnet with a liquid nitrogen, like that comes in a tank like this. So the magnet is super cooled inside, almost absolute zero temperature, negative 273 degrees Celsius, and so that there is no resistance, and so that we could create this really strong electromagnet. And so that's what's in there. So we just have to be really careful. So you should not really have a reason to get really close to the magnet, but please don't I guess get too close unless you have a really good reason to. And above all things, please do not set your foot on this, because that will fall. That could actually damage the magnet here. Okay, this is not a platform to set a foot on. So once the NMR sample is in the auto sampler, so usually for that part you need to get help from the instructor or a trained lab assistant. And once that's on there, what you want to do is to open the JEOL Delta software, which is this icon. Yeah, I know there's like too many icons on my desktop, but please don't look, because it's this one. Just double click and whatnot, which will pull up the Delta software, which looks like this. Go ahead and click on the icon that looks like the magnet. By default, it should get you to what's called the walk-up mode, which should look like this. Right now, I am logged in as my own user, but you guys will use the Chem 211 212 user. And if you click on that and then click on login, you should be able to log in without any password. Which will get you to this screen, and you'll notice the slot numbers are on the left, like so. And remember that for Chem 211 class purpose, I want you to use slots, or for most class purposes, even if it's not 211, whether it's 212 or Chem 3027, I want you to use slots 1 through 10. The rest are reserved for either research purposes or the maintenance purpose. And remember, 24 is the one that you should never ever use under any circumstance. So what you do is you want to put in a sample name. This is going to be the file name that is going to be given to your NMR file. Or at least your file names will begin with the sample name and ends with the type of experiment you're doing with the NMR. So I just put in the sample name and then the email address in the comment column. This is very necessary because you need to retrieve your data, and the way that it's going to happen is once the acquisition is done, this machine is going to, when I say this machine, it's not this computer, but this is the computer that will send it to you. All the acquisition happens here, the sample goes in here. Once the acquisition is done, that white big computer called the console is going to send you a raw data file to the email address you put in this column. And then the next thing you need to specify is the solvent that your sample is in. For most of you, that is going to be chloroform D. Some of you may need to put your sample in more polar solvent like acetone D6 or DMSO D6. Basically, none of you are going to have this, but my particular sample I'm using for this demonstration happens to be in a rare solvent called DMF D7. So I'm going to use that. But again, I just want to mention, none of you are going to use DMF. You're going to use chloroform. And for the method, this is the actual experiment for Chem 211 to 12. These are the experiments that are available. Depending on the class username that you use, there's going to be different sets of experiments that are available. If you're watching this for Chem 327, there should be more options available here. But for now, I just need to get both the proton and the carbon, so I'll check that. So once you set the solvent in the method file, method I should say, you should click on this icon to look at the parameters. You don't really need to change anything, and in fact, please don't change anything, perhaps except for carbon scans. If you used quite a bit of the sample in your NMR tube, like say close to 20 milligrams, you could probably leave this as is and not even change anything. Now, if you have like somewhere between 10 to 15 milligrams or so, you might up this to 512 or so. If you have less than 10 milligrams, consult your instructor or lab assistant. They might suggest a certain number of scans for the carbon scans. Now, if you close that, it'll calculate the estimated amount of time that you need to spend, or this particular set of samples or experiments will take. So this is going to take 29 minutes. force tune is usually a good idea for 2D experiments, but if you're just doing 1D proton and carbon, it's really not that important. But if you're curious what that does, you can click on that. But that adds a couple minutes to the acquisition time. And what you want to do is you make sure that email data is checked, okay, and you can, unless there's a reason to delay the acquisition of your sample, you don't need to do anything with the scheduling. And once this is all done, you can click on this submit button, and that will get the experiment going. Now, if you're kind of setting this up as a group, the instructor might, or lab assistant might encourage you to do that. A bunch of you might put in your sample name to the that accords with the right slot number where the sample is, and then your email, the solvent, the experiment method, number of scans, and so forth. So if there's a number of entries here, then you don't want to hit the submit button every time you put in an entry. You want to wait for the whole group to add all the entries and then hit submit all for the group. Okay. In this case, I only have one sample, so I'm just going to hit this, and that will start the experiment. And what you should hear is you're going to hear the autosampler moving like this. So you notice the sample that was in the magnet came up right there. And then it just, autosampler switched to sample slot number 1. So the my sample that was in slot number 1 went into the magnet probe. So it's inside this thing now. And now what it's going to do is, first you notice that this screen turns on. That is the tuning of the probe. And then it's going to next do what's called a gradient shim. The shimming has to do with getting the magnetic field of this electromagnet inside the exactly lined up with the sample that you put in, the specific sample that you put in. So that process is going to begin, and that will be reflected in what's displayed on the screen here. So right now it's just doing the tuning, right? And then in a minute it's going to say gradient shimming. It's going to run the first experiment, which is proton, and then the carbon experiment. And once they're all done, it should email you the data. So once the sample is submitted, you can go ahead and close all of this because the actual experiment is being run by this computer, not by this computer. This computer just asked the console through networks to run those experiments, and then all the experimental data and protocol is coming from this. So you should go ahead and close the Delta software as soon as you submit your sample, and please don't keep it open, but close it up because only so many people can use Delta on campus at a time. So I don't want you to leave that open and then log out.